Did it show the board? Okay. So I will start with, okay, where we are here, it's the node 3. And this is the third structure of the same thing. So I write S3 in front of that structure on my notes. The question being asked is, that's the unlikely. This is the unlikely. And I think it's a good question because someone just asked me, if you said unlikely because there are too many charges. If you point this one here, start from the lone pair and point into the bond, then that's going to form a double bond. Okay, this way you have less charges. Well, this counts as a correct resonance structure. The answer is yes, because if you compare this structure, it's actually the major. It's actually the major. It's the major one was written in node 3 with a 1 on top of that. And that's, if you compare them, like it's the major resonance structure. Did you all see that?
Yes.
Okay, yes, question.
The nitrogen on the first example and the carbon on the last example, how did you know that they were a sextet instead of an octet?
Okay, so we can count that. But are we good with this?
So for that one, there's 3 resonance structures, or is it 2?
There are more than, okay, I'll finish this one first, okay? For this one, there are major, minor. If you write unlikely, you can still get points on if ask you to write the resonance structure, but you should always identify that one as major. Because when you write resonance, you are supposed not just write the structure, you're also going to show you how this one, the arrow pushing, right? So this will be counted as correct answer because you did get to a major correct contributor. Yes?
I just want to know, how would we know when a compound is major and minor?
Okay, that's been covered in today's back of the notes. There are 4 rules. And then this one is, this one we have set rule 2 and rule 3 to go over which one is major. The reason this one is major is compared to a minor structure in our back of the notes is because your oxygen, rule number 2, negative charge should be located on a more electronegative atom. In this case, it's oxygen. Compared to your example here, on your back of your notes 3, there's a number 1 right in front of that. Your negative charge is located on carbon. Carbon is not as electronegative as oxygen, so carbon should not take that negative charge.
Okay, so the major would be the contributor that follows the rule, and then the rest.
Okay, let's just make things clear. There are total 3 structures I draw on my notes with this one. This is minor. This is minor. This is major. Our notes compare this pair first. And then I showed a wrong structure. Also, my notes compare this pair. Are we clear on what I'm saying? Okay. When I compare these two, oxygen is more electronegative than carbon. That's why this is major. When I compare these two, this one has more charge separation than this one. So this one is unlikely. Yes.
So it's already like less likely or like more minor than the minor.
Yeah, so I meant to use unlikely to show that's even minor.
Oh, okay.
So on the quiz, would you expect us to draw the unlikely also?
It depends on the TA. I did not make the quiz. I will say if you write this, I will still count correct. But you as long as you don't identify this one as major. Are we good? Okay. You.
Will you ever have resonance structures which are equally major?
Yes, that's the first example we see in the class.
So would we just say both of them are?
Yeah, that's the real structure, 2 equal contributor.
Okay.
That's the first thing we learn in the class. Yes?
So about rule 1, I noticed like for our last example,
Yeah.
that the minor contributor. For
Doesn't have
oxygen-
charge. Yeah.
Yeah, it doesn't have charge, and the oxygen fulfills the octet rule. But for rule 1, does the central atom take priority?
It's hard to say which one is the central atom. Is when you want basically hopefully all of the atom can fill the octet rules. Yeah. So I meant to set example of the last one saying, you see 6 stats that's already lower the priority.
Okay.
Even this one has less charge distribution. Yes.
I have a question on the one above. So I did this structure instead, and in this, the nitrogen has an octet, but would this still count as a resonance structure? I went from here to here. So I moved the double bond over here to a lone pair for the nitrogen in the center to get this structure. Because then the charge would be 0 for both nitrogens, but this would be a sextet.
No, this one, if you you move. Okay, you move.
This arrow is wrong. This shows here. So
Okay.
I moved this double bond here to the nitrogen here as a lone pair, and then I got this structure.
Yeah, that would count. Yeah.
Okay. But it would be unlikely because nitrogen is a sextet. This
Yeah.
Nitrogen?
Yeah.
Okay.
Yeah.
But can I still draw this on like?
You can still draw this.
Okay.
Okay. Are we good with this one? And we can come to a sextet. Are we good with it? Okay. Can we post the video? So I'll send like a one by one. I'm going to erase the board.